Hello everybody, my name is Rene Nájera. I am an epidemiologist. This is me using the ChatGPT data analyst. I got curious when I saw it today, and I know it's been out for a little while, but I do all my coding and I do all my data analysis on my own. I just thought this was interesting and I want to see the capabilities of it. So this is me walking through it for the first time, and you get to see how I use it. So I'm going to load some fake data. I have a fake data file on here. Fake Outbreak data set right there, and you can see all the other coding that I've been doing. And so this is a fake data set of an Outbreak investigation. It is the results of a survey, or they are the results of a survey on what people ate or did not eat at a party. And it also shows who was sick and who was not sick. So let's it's gonna give me the code in Python, which is good. I could have asked it initially to do it in R, and then I could have done it in R. But here you can see that it's showing me the first few rows. All this is fake data, by the way. Okay, so one of the things that we do in outbreak investigations is look at the attack rate. So calculate the attack rate by food item. Tell me, then rank the food items by attack rate highest to lowest. So the attack rate is the number of people who are sick out of all the people who ate that food. So, and it tells you a little bit about that here. So let's see. It's doing all the code and it looks good. It's creating a function for calculating attack rates, and then it is applying it to that. So here we see the baked potato has the highest attack rate and the salad has the lowest attack rate. So it is interesting here because the water, and I'm looking at the attack rates on my R code, and it checks out the lowest 10.2 for salad. Yep. Oh, good. Okay. And for bottled water, 31.9, even though everybody had it, 31.9% of the people who had the water were sick. So what we do in epidemiology, field epidemiology, we look at the highest attack rate, and that is our suspect food, baked potato. And the lowest is salad. So salad, we ask the question, is it a protective factor or is it not? And so the baked potato. So what I'm going to do next is I'm going to do a cross tabulation. Perform a cross tabulation of each food item against ill or not ill. Show the chi-square statistic and resulting p-value. So let's see what it does. Contingency tables, yes, and then you do the chi-square on the contingency tables. So it is creating that function. All right. Nice. So we can see that there are statistically significant p-values. That doesn't mean that that's the add on the cost of food, but we can go back and see baked potato statistically significant, and it had the highest, and then salad statistically significant, and it had the lowest. And the other ones are not statistically significant. Chicken was also statistically significant. So what was the attack rate for chicken? 25.4. So is it possible that somebody had the chicken and salad, baked potato, right? But this is just telling us, confirming to us that the statistics around, and actually the bottled water chi-score is 0 because everybody had bottled water. So if everybody has bottled water, there's no way of calculating the odds ratio for that because there's no odds of people who did not have the water, right? It's calculating the odds of being ill given that you ate the food over the odds of being healthy given that you ate the food, and that is a chi-square statistic that it calculates. And so let's ask it for that. Calculate the odds ratio, and it's 95% confidence interval for odds of illness given the food item eaten for each item. And here, if you know your statistics, if you know your statistics, p-values are less than 0.05 if the 95% confidence interval does not include 1. So let's see. 2 by 2 tables, and then the odds, and then the odds ratio, and 95% confidence interval. Again, it's doing it all in Python, so you can really copy this and then just replace the data with something that you're using. And I created that fake data using R. Okay. All right, it's working on it. It looks good. Calculating the odds ratio, contingency tables. There was an error likely caused by a contingency table that didn't have all the necessary dimensions. Okay, so it's the water. That's the water. I can tell for sure it's the water because, again, there were no people who did not have the water. So it's going to run a test to see if a contingency table can be built, and if not, it will not do the, see, right there, it's the water. So good. Very good, very well done. And of course, you know, this is the computer is doing it for you. It's a tool. It does not replace your own knowledge of epidemiology and biostatistics. But you can see if it was the strongest association is baked potato, stronger than the chicken. The chicken is actually protective. The odds ratio is less than 1, and the salad is also protective. So the salad and the chicken, you're less likely to be sick if you ate those than if you had the baked potato. So. Let's see, anybody else is a significant risk factor. Fish, 1.4, and it was 1.07. So let's see what the p-value was for that. Fish, p-value is 0.01. So it could be the fish. It could be a combination of the fish and the baked potato. But, I mean, 57, odds ratio 57 on the baked potato. So my next step as an epidemiologist would be to get samples of that baked potato, actually get samples of everything and send that over to the lab if I still can find some of that food. But definitely look at the baked potato and definitely looked at the fish as well. Everything else crosses 1 or is not statistically significant. And I'm really way less worried about the salad and less worried about the chicken in this instance. But I would not just go for the baked potato and the fish. There could be some confounding in here. I would also look at the demographics of the people who got sick, their age, whether they had something else. You know, did they get any cake or any other food that is not mentioned in the questionnaire? Did they bring in their own food, etc.? So that's kind of the analysis that I would do with that. So this is very well done. Kudos to the bot, the artificial intelligence that did this. And so this is well done. I don't think there's anything else that I would have done. I have my code over here on the right, and you can't see it, but I have my R code, and yeah, it looks exactly the same. So. Very well done. This was in Python, so I might actually use some of this Python code for examples for classes and whatnot. So with that, this was the epidemiologist approach to data analysis during an outbreak investigation. There are a couple of other things that I could have done with the data as well. I could have generated, if I had the onset dates, which I don't. If you go back, I don't have onset dates on here. I'm going to add onset dates so I can create a epidemic curve, and then that's another tool that we can use. So here, what is an epidemic curve, and how can it be used to understand an epidemic? Let's see if we can draw that from somewhere. Yeah. Good. The shape is what you can tell if it's point source or perpetuated or continuous. You can determine the incubation period as well, when the outbreak started. All right, so yeah, that's pretty good. All right, that's it. Thank you for watching.